Hey everyone, Mrs. Keener here. We're going to just start this video off, the first lesson of the year for AP Calculus, properties of limits and evaluating limits graphically. So we're going to start off with the definition of the limit. Limits give us a language. So limits were invented, okay, not discovered. They were invented. Limits give us a language for describing how the output of a function, oh my lights, are we good? Can you guys see that okay? Now it's yellow, blue, then yellow. Function I'm on a time limit, so I need to go. A function behave as the inputs approach some particular value. Okay, real quick, just to review about outputs and inputs. So the inputs, are always x values or the domain. Brain's a little foggy coming off of summer here. And then what would that make the outputs? The outputs are y values, also known as the range if you actually have a point. Limits give us a language for describing how the output of a function behaves. How the output of a function behaves as the inputs approach some particular value. Now let's use the blah blah blah. Wow. Okay, this first day of school, 2018, and I'm just making this video, and I thought very highly of my abilities, but now words are getting all mixed up, so bear with me, okay? So here's how you write a limit or describe a limit in symbols, and what this means in words goes like this. The limit, that's what LIM, the limit of f of x, so that could say g of x, h of x, the limit of f of x, and then you go down here, as x, and the arrow stands for the phrase, or the word, sorry, approaches. As x approaches c, then you go to the equal sign, is, or equals, EQUAL, equals a number L. Okay, so this is the definition of a limit, this is a limit in symbols, and this is explaining the symbols in words. So if you would like to somehow decorate this, then that would be awesome. Okay, I'm now going to pause the video. This is pretty, these are like, oh man, I wish it looked better than that. Oh well. Make yours look better. I'm going to pause and I'm going to fill in the table below. It's kind of boring. It doesn't really need explanation. It's just the properties of limits, but it's so easy, but we can't ignore it, okay? If you have one limit named L and the other limit named M, here are all the things you can do with L and M. So I'm going to pause, fill it in, and so here we have the properties of the limits, and ready, get, set, go. If you are adding two limits in symbols, then you can add the values together. You could subtract two limits together. You can multiply two limits. You can multiply a limit by a constant, like 5 times the limit, if there's a constant in front of your limit. You can divide limits. You can raise a limit to a power, and so you're copying this, right? You get a pause to copy. And the limit of just a constant is that constant. So it doesn't matter where x is approaching. If it's just 7, not 7x, or 7 plus x, if it's just 7, then the answer is 7. And we'll go over that, okay? I learned how to paint my nails this summer, so I was like so excited to show my videos that I painted nails now. I hope you enjoy. Here we're going to practice the properties. A lot of our practice this year, you guys, will be with F and G's. So it's a lot of substitution, and you need to go and find what is F equal to and what is G equal to. So here's our first example. If the limit of f of x as x approaches 3 equals 2, and the limit of g of x as x approaches 3 equals -4, find each of the following. So, example 1, part A. The limit as x approaches 3 of 5 times f of x divided by g of x. So on the previous page, we said you can multiply any limit by a constant, and then you can divide limits. So we're just going to substitute. Ready? We're going to keep the 5, and we're going to multiply by the limit as x approaches 3 of f of x. Well, the limit as x approaches 3 of f of x is 2. So we have 5 times 2 divided by the limit as x approaches 3 of g is -4. So that's it. We're just substituting it in, and then we'll simplify. Okay? Reduce by 2, so we have -5/2, right? And the negative stays in front. It doesn't stay in the denominator. Okay, so what are we going to do here? We're going to take the limit of f and add it to 2 times the limit of g. So this will equal 2 from f, right? 2 plus 2 times the limit of g, and that's -4. So we have 2 minus 8, and 2 minus 8 is -6. Let me know all the time if I ever make a mistake. I try to not make mistakes on the videos because I can't edit them, but let me know if you ever think that I've made a mistake. Okay, so the whole point of this is to not do this, right? So this is going to equal the square root of 4 times the f limit. So the f limit is 2. Okay, what's 4 times 2? It's 8. And now we have a square root. The square root of 8 is 2 square root 2. Now, there is no square root rule on the front, but there was a power rule, and the square root is the 1/2 power, remember? Okay, we're still going here, yeah? What are we going to do? The limit of g divided by 8. And we get this, I hope. And what are we going to do here? 3 times at the f limit minus the g limit. Oh, it's minus a negative. So minus a negative turns positive. And last but not least, here we go. F times g. So we have 2 times -4 divided by 12. -8 over 12 simplifies. Greatest common factor is 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So we have -2/3. Okay, you're going to try example 2. When I say you try, that's a mandate. That's a requirement. You must be able to do this. Okay, so we're going to check this when we get to class tomorrow. Okay, the next time I see you. So I gave you an example. It's not that hard. Now you're going to do this. All right, on your own. I'm going to flip over here. When does a limit exist and when does it not exist? I also have a chart, an anchor, like notes in the classroom on the limit existence theorem. But here we go. A limit only exists when, can you guys see the green? I don't know if you can. Okay. That's not how you spell limit. Oh, first time using this. Where's my whiteout? You guys, I cleaned out my cupboard. I have so many whiteouts. Like I have a collection. I'm a hoarder, a whiteout hoarder. The limit. What's it called? A stockpile, right? The limit exists when the limit from the left equals EQUALES equals the limit from the right. And we're supposed to write this in symbols, and did not leave enough room. So let's put it up here. Okay, so important, ready? The limit as x approaches c from the left, that's what that little negative sign there, must equal the limit as x approaches c from the right, and it has to be the same function. So we're not saying f and then g, okay? Oh, Katie. New people, welcome to my class. I usually don't make this many mistakes. Just waking up from summer. Okay, I only have 15 minutes on my videos, so we're getting close to the end. We're going to just do as much of these as we can. Ready? Example 3. The limit as x approaches 2 from the left. So that's not -2. That means from the left. So from the left, as you approach 2, where is this function going? Is it landing at a single number? It is not. It's just going and going and going up to positive infinity, right? So we actually say that that limit does not exist. Because in order for a limit to exist, it has to equal the same number. And they don't equal the same number because they're not hitting a number, they're going to infinity. So coming from the right, here, plus sign means from the right, this also does not exist. You can write D and E as long as you know what it means. What is f of 2? That is the point. What is the actual coordinate point when x equals 2? Is there a point here? No. So that also does not exist. Isn't this an exciting example? Does the limit exist or not? Why or why not? No. And a good reason is that it's approaching infinity. Let's do another one, maybe a little bit more exciting. The limit as x approaches 2 from the left of the function. So here's 2. Now you have to, this says from the left. So you go to the left side of your graph and you hop on your function. So I'm not up here, I'm not over here, I'm not at 2. I hop on the function on the left side and you sing a little song as you go in your little travels here. Do 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 do. Do 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 do. Do you see how x is approaching 2 from the left side? So I'm going towards 2. This answer here is going to say, what is the y value? So where did we land? We landed at 3. So the limit as x approaches 2 from the left equals 3. The limit as x approaches 2 from the right, so now now go to the right side of your graph and find the function. So not over here, not up here, on the arrow. Do you see that? And go towards 2 coming from the right. So from direction is really important here. You have to know your left and right, everyone. This is left and this is right. So coming from the right, oops, I forgot to sing my song. Do 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 do. See how I stopped? Do 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 do. Okay, it doesn't matter if there's a hole there or not, okay? What y value are we at? We're at the y value of -3. The reason limits were invented was to talk about what's happening when there's a hole. So if you just give up and go, oh, no math, there's a hole, we can't do anything, well, that's dumb, okay? There's a hole. Well, where is the hole? The hole is at -3. And we just name it a limit. What is f of 2? Where is the point, you guys? There's only one point at 2. Where is it located? So we're at x equals 2, go up and go down. Do you see the point? Where is the filled in circle? The filled in circle is here. And what's that? Y value? 3. So f of 2 equals 3. That's the coordinate point, 2, 3. This means the same thing. This and this, same thing. Coordinate point. Does the limit exist or not? How do we know if a limit exists? The limit exists when the limit from the left equals the limit from the right. Does the limit from the left equal the limit from the right? The limit from the left, is that equal to the limit from the right? No. The limit from the left is 3. The limit from the right is -3. Here's how you explain the reasoning. The limit as x approaches 2 from the left of f does not equal the limit as x approaches 2 from the right of f. Try number 5. Thanks for watching.